Okay, so here we see a smoldering hot skillet on a very hot stove. Today we're going to briefly talk about condensation, evaporation, relative humidity, and something called dew point. So this is an extremely hot surface. This is very cool water. Very quickly, the cooler water was immediately turned into gas, or into vapor. Okay. These things happen naturally on the planet. Similarly to when you are in the shower, the bathroom is very hot. Okay. That water vapor is going to condense on cooler surfaces, or like when you're in a car and the heat is on, the cooler windows you can write on because the windows are cooler than the air in the car itself. So that very warm air is going to condense, going to turn back into a liquid on that solid surface, the opposite of what you just saw on the frying pan. Okay. Now, understanding humidity, you need to understand 3 points that are in tandem with one another. Okay, you have something called dew point, humidity, and then you have something called relative humidity. Okay, humidity is the actual measurement of how much water vapor is in the atmosphere. Okay, relative humidity is the amount of water vapor that's in the atmosphere relative to how much water vapor the actual atmosphere can hold. Okay, why is this? This is because as the temperature increases, okay, the amount of actual water vapor that the atmosphere can hold also increases. When it decreases, the amount of water vapor that the atmosphere can hold decreases. As you can see with these 2 glasses of water, they're both at 50% capacity. Okay, they're both 50% full. Okay, but one has a lot more water in it than the other one. That's because this glass of water is much larger. You can see it with your eyes easily. This one is much smaller, so it can't hold as much. Okay, now something called the dew point is when the actual water, the water vapor in the atmosphere, is at full capacity. It literally can't hold that much water. So by virtue of relative humidity, that means that what the dew point is going to be contingent on what the temperature is. When does the atmosphere hit that point when it can't hold any more water? Okay, so as I just showed you right here in a visual diagram, okay, these are 2 glasses. Okay, they're both at 50% capacity. That means that they're both at 50% relative humidity, relative to how much actual volume of water both of these glasses can hold. Okay, they're both at 50%. Now, does that mean that they both have the same amount of water in them? Certainly not. Okay, this is why we feel humid at certain times and why we don't feel humid at other times. This is also why, because of what explains the phenomenon of dew, okay, which we're going to talk about in a little bit. So as I said, the dew point, this is when the atmosphere literally can't hold any more water vapor because of what the temperature will allow. Okay, so let's use something that you guys would know. When you guys feel humid, okay, during the summer, let's take a very oppressively hot and humid day in New York City in August. Okay, let's say that the temperature is 98 degrees. Okay, it's 1 o'clock in the afternoon. The relative humidity is at 50%, just like these glasses of water. Okay, now if the relative humidity is at 50%, that means that if it was cooler or warmer, that means that actual amount of humidity in the air wouldn't change, but what would change is the relative humidity, because now you have a warmer or cooler temperature allowing more or not allowing more water vapor into the air. Okay, so changing that actual total relative humidity that the atmosphere can contain at that time. So let's say it's 1 in the afternoon, it's 50% relative humidity, it's 90 degrees. That would mean, and you can look this up online, there's dew point calculators, that would mean that if 68 degrees was hit rapidly right after this 90 degrees, that means that boom, the relative humidity would now be at 100%. That water would start converting back into a liquid form. Okay, and this really does happen. This is why car windshields and blades of grass and small objects are wet at like 6 in the morning in New York City after very, very hot summer days, hot and humid days the day before. Okay, so let's say that boom, it's 4 a.m. after a really hot and humid day in New York. Temperature drops to 68.8 degrees at 4 a.m. All of a sudden, you're at 100% humidity. You get up, you come out of your apartment in the morning. Now there's condensed liquid that formed on the surface of small solid objects. Okay, that's because the maximum amount of water vapor that the air could hold changed so rapidly, but that water vapor didn't go any. Well, it did. The water vapor left in the form of evaporation, but the rate of condensation trumped the rate of evaporation. Okay, because the temperature changed so drastically, and there was just so much water vapor in the air that day. Okay, so that 50% margin just rapidly changed to 100%, and that's what the dew point represents. That's what a full glass of water represents. That means that the atmosphere couldn't hold any more water vapor. It had no choice but to convert back into liquid form, and it did so on solid objects. So this is kind of a rare phenomenon, but it very much exemplifies relative humidity and dew point. We can see it right before our eyes because there's liquid on the ground and it didn't rain. So to sum up this lesson, the higher the temperature, the actual amount of water vapor that the atmosphere can hold increases. The lower the temperature, the less water vapor that the atmosphere can hold. Okay, 50% relative humidity in cooler temperatures and 50% relative humidity in warmer temperatures would not feel the same. Okay, these are very different amounts of actual water that's in the atmosphere. Okay, because of the actual amount of water vapor that those warmer temperatures could hold. Okay, hot day in New York City, 90 degrees, 50% relative humidity with a dew point of 68. And like I said, you guys can do this online. You can calculate dew points, put in the relative humidity, put in the temperature, and it'll give you the dew point to a T. Okay, that dew point will always represent when that glass of water is going to tip. Okay, 68.8 degrees hits. All of a sudden, boom, 100 degrees hits, 100% hits. That saturated atmosphere can no longer contain that water, and it converts right back into liquid form. Thanks, guys.